Hello everyone, this is Anirudh. Today we'll learn a new chapter in maths, that is integers. So let's start. First of all, what are integers? Well, integers are the numbers which include whole numbers along with negative numbers. It is denoted by the letter I or Z. So, what are whole numbers? Well, the natural numbers like 1, 2, 3, 4 along with 0 form whole numbers, and these whole numbers along with negative numbers form integers. So integers are denoted by the letter I or Z. It extends endlessly along both the directions on a number line. Example, -3, -2, -1, 0, 1, 2, 3 and so on are all integers on number line. So this is an integer number line. 0 is neither positive nor negative. 0 is in the middle of the number line. It is neither positive nor negative. To the right side of 0 are positive integers and to the left are negative integers. Positive integers are always greater than negative integers. 0 is lesser than every positive integer and greater than every negative integers. Now, as you go on moving to the right of the number line, the numbers increase, and as you go to the left, the numbers decrease. Properties of integers. Well, there are 5 properties of integers, which are closure property, commutative property, associative property, identity property, and inverse property. In this video, we'll discuss about closure property, commutative property, and associative property under integers in the basic operations, that is addition, subtraction, multiplication, and division. So let us start with closure property. Closure property. So in closure property, when you add, subtract, multiply, or divide, you should get an integer as the sum, difference, product, or quotient. So, like A plus B, the sum should be an integer. So this is closure property. Let us check. A will give number to the variables. A will give us 8 and B will give us 10. Now A plus B should be an integer. So let us check. 8 plus 10. It is 18. 18 is an integer. So we say that addition is closed under integers. Now let us look at subtraction. Well, we'll take the same numbers for the variables. A minus B, which is 8 minus 10. Minus 2. Minus 2, though it is a negative number, it is an integer. As I said, negative numbers are also integers. So, we say that subtraction is closed under integers. Now, multiplication, we'll take the same numbers. A into B, which means 8 into 10. 80 is also an integer, so we say that multiplication is closed under integers. Now we checked addition, subtraction, and multiplication under closure property. Now let us check division. Now I have underlined the whether they are closed or not. Same number A divided by B. which means 8 divided by 10, which will give you the answer as 0.8. Well, decimals are not integers. Decimals are not counted as integers. When we convert decimals into fractions also, they are not counted as integers. Fractions are also not integers. So, this is not an integer. So, we say that division is not closed under integers. So, under closure property, addition, subtraction and multiplication are closed. Division is not. Now the second property is commutative. Well, here when we add, subtract, multiply or divide two integers, and when we reverse the numbers, we should get the same integer as the sum, difference, product or quotient. So A, we will give the variable as number as 7 and B as 5. A plus B is equal to B plus A. So 7 plus 5 is 12. Now let us reverse this. 5 plus 7 will give you the same integer. So we say that addition is commutative under integers. Now let us check subtraction. Well, this time we'll take A as 7 and B as 5, the same numbers. A minus B should be equal to B minus A. So A minus B is 7 minus 5, which is 2, and B minus A, that is 5 minus 7, is minus 2. So we got different integers. So we say that subtraction is not commutative under integers. So addition is commutative, subtraction is not commutative. Now multiplication. A into B should be equal to B into A, which means A into B is 7 multiplied by 5, that is 35, and 5 multiplied by 7 when we reverse is 35. So we get the same integer as the product. So we say that multiplication is commutative under integers. So addition and multiplication are commutative while subtraction is not. One more basic operation is there, that is division. Let us check that also. A divided by B is equal to B divided by A. So first we'll do 7 divided by 5. It's 1.4. As I said before, decimals are not counted as integers. Well, we'll just reverse this and check. Anyways, it's not commutative. Well, just reverse it. You will get the answer as 0.7143. So we got different integers and decimals are not counted as integers. So we say directly that division is not commutative under integers. So like in closure property, division is again not commutative under commutative property. Now the third property is associative property. Associate. Well, it is similar to commutative property, but there is a difference. In associative property, we use 3 integers, while in commutative property, we use only 2 integers. So, in addition, we say like this: A plus B plus C is equal to A plus B plus C. So here we have three integers, so let us give them numbers. A will be 4, B will be 5 and C will be 6. So 4 plus 5 plus 6. So in maths we first solve the brackets. So let us solve it. 5 plus 6 is 11. So 4 plus 11 will give you 15 as the answer. Now let us reverse it. That is 4 plus 5, bracket close, and 6. So brackets comes first. So 4 plus 5 is 9. 9 plus 6, so 15. So we get the same integer as the sum. So we say that addition is associative under integers. Now let us check subtraction. Here also the same thing, but the signs are changed. A minus B minus C will be equal to A minus B minus C. We'll give the same numbers to them. Now 4 minus 5 minus 6. So we'll first solve the brackets. That is 5 minus 6 is minus 1. So 4 minus 1. In subtraction of integers, in the next upcoming videos, you will see that in subtraction of integers, when two minus signs are near to each other and there is a bracket between it, bracket means multiplication, and when there is a bracket, we should multiply minus into minus. Minus into minus we will get as plus. So it will mean that 4 plus 1. So 4 minus minus 1 is 4 plus 1. That is 5. Now let us reverse these. 4 minus 5 minus 6. Brackets first. 4 minus 1 is minus 1 minus 6. You will get the answer as minus 7. You get different integers, which means that subtraction is not associative under integers. Now the next one is multiplication. A into B into C will be equal to A into B into C. Now the same numbers. So 4 into 5 into 6, which will be 5 into 6 will be 30. So 4 into 30, which will give you the answer as 120. Now let us reverse it. That is 4 into 5 into 6, which means 20 into 6, that is 120. So we get the same product in both the cases. So we say that multiplication is associative under integers. Now let us check division also. Well, in previous both properties, that is closure property and commutative property, division was not closed and division was not commutative. Well, let's check in associative. B divided by C is equal to A divided by B divided by C. So 4 divided by 5 divided by 6. 5 divided by 6 will give you the answer as 0.8333. Well, let us check 4 divided by 0.8333. 4.8002, which is not an integer. So we'll leave division. We can directly say that division is not associative under integers. Well, in closure property, addition, subtraction and multiplication were closed under integers while division was not. In commutative property, addition, subtraction and multiplication were commutative, but well, even subtraction was not commutative. So addition and multiplication were commutative while subtraction and division were not. In associative, addition and multiplication were associative while subtraction was not. Subtraction and division were not associative. So in the next video, we'll check the remaining two properties, that is identity property and inverse property, and we'll learn about absolute value or modulus. So that's it for this video. Hope you liked it. Thank you and stay tuned for the next video. Bye.